In this lecture, we prove a few corollaries of Lagrange's theorem. What was Lagrange's theorem? That if G is a finite group, order of any subgroup will divide order of G. Now, as a consequence of Lagrange's theorem, the first corollary we prove is if G is finite group and if A is any element of G, then order of A must divide order of G. Let us prove it. Suppose G is finite, that means order of every element of a finite group is finite. That means order of A is also finite. Suppose order of A is some positive integer m, and now define a subgroup H which is cyclic and it is generated by A. So H में क्या A के different powers हो जाएंगी. So you have a square, a to the power m minus 1, and last element a to the power m is identity because order of A is m, तो वो मैंने first लिखा है, right? So order of H is same as order of A, which is m, right? Now by Lagrange's theorem, order of a subgroup divides order of that the main group. So this m must divide order of G. So order of H divides order of G. So this m must divide order of G. But what was m? M was also order of A. So this proves that order of an element always divides order of the group. And this happens only for finite groups, obviously. Next corollary is if G is a group of finite order, then you take any element A in G, then A to the power order of G must be identity. This doesn't mean that order of A is same as order of G. It simply says that if you take any element of G, then G raised to the power, A raised to the power order of G will always be identity. Let us prove this. Suppose order of G is some positive integer n and order of A is some positive integer m, then by the above corollary we have proved that order of A divides order of G. That means order of A is m and it divides n, right? So this means this n is a multiple of m. So this n can be written as m times k. Okay, now remember order of A is m, so A to the power m will be identity. Now look at A to the power order of G. I have to prove that this is also identity. What is order of G here? N, which is a multiple of m. So A to the power order of G is A to the power n, but look at this point, n is same as m times k. So this is A to the power m to the power k. But A to the power m is identity. Why? Because order of A is m. So this becomes identity, right? That means A raised to the power order of G is always identity. Next corollary is if G is a finite group of prime order, then G is cyclic. So this corollary says that if you have a finite group of prime order, it will always be cyclic. Suppose order of G is a prime number P and I take H a subgroup of G. Then by Lagrange's theorem, order of H must divide order of G, right? So order of H must divide this prime number P, but P is a prime number. So the divisors are either 1 or P. So that means order of H can either be 1 or P. That means H में या तो एक ही एलिमेंट होगा या सारे के सारे P एलिमेंट्स होंगे. That means H will either be the singleton set containing identity element or it will be whole of the group G. So that means H is a trivial subgroup of G. So हमने क्या प्रूव किया कि जब order of G एक प्राइम नंबर होगा then G has no proper subgroups. It has only two trivial subgroups. Now suppose I take an element A in G which is a non-identity element. Then clearly order of A is strictly greater than 1. See, E is the only element, identity element is the only element जिसका order 1 होता है. सो अगर हमारे पास एक एलिमेंट है जो नॉन आइडेंटिटी एलिमेंट है तो उसका ऑर्डर स्ट्रिक्टली ग्रेटर देन 1 होगा, राइट. नाउ टेक H टू बी साइक्लिक ग्रुप जनरेटेड बाय A, देन क्लियरली H इज़ अ सब ग्रुप ऑफ G. वाई? A इज़ इन G. सो A के जितने भी पावर्स आप लोगे वो सारे फिर से G में हो जाएंगे. दैट मीन्स H के सारे एलिमेंट्स G में हैं. दैट मीन्स H इज़ अ सब ग्रुप ऑफ G. And then we also know that order of a group is same as order of its generator. So here order of H is same as order of A. But यहाँ पे हमने कहा कि order of A greater than 1 है. That means H is not equal to the singleton set containing identity element. And also we have proved that G has no proper subgroups. So G has no proper subgroup. और H सिंगलटन सेट कंटेनिंग आइडेंटिटी एलिमेंट के इक्वल नहीं है, तो H क्या होगा? H हैज़ टू बी इक्वल टू G. सो H हैज़ टू बी इक्वल टू G, बट H इज़ साइक्लिक ग्रुप जनरेटेड बाय A, hence G is cyclic group. Next corollary, every proper subgroup of an infinite cyclic group is infinite. सो कोई भी अगर आपका साइक्लिक ग्रुप है जो इनफाइनाइट है तो उसके प्रॉपर सब ग्रुप्स क्या होंगे? दे मस्ट बी इनफाइनाइट. प्रूफ, सपोज G इज साइक्लिक ग्रुप जनरेटेड बाय A एंड G इज गिवन टू बी इनफाइनाइट. सपोज H इज़ अ सब ग्रुप ऑफ G. हमें क्या प्रूव करना है? कि ऑर्डर ऑफ H इनफाइनाइट है. नाउ सिंस G इज साइक्लिक एंड वी नो दैट सब ग्रुप ऑफ अ साइक्लिक ग्रुप इज साइक्लिक, सो H must be cyclic. Suppose H is cyclic group which is generated by A to the power m, where m is the least positive integer such that A to the power m is in H. तो हमने ऐसे H को डिफाइन किया है कि H साइक्लिक ग्रुप है और ये A to the power m से जनरेट हो रहा है, बट m की प्रॉपर्टी क्या है? m is the least positive integer such that A to the power m is in H. And we'll prove that H is infinite, right? But suppose H is finite, we'll get a contradiction. Suppose H is finite, so order of H must be a finite number. Say order of H is n, and also since order of H is same as order of its generator, so order of H is same as order of A to the power m, and I am assuming it to be finite, so suppose it is n. That means A to the power m raised to the power n must be identity. That means A to the power mn is identity. अगर A की कोई पावर आइडेंटिटी होती है तो उसका मतलब क्या होता है? कि ऑर्डर ऑफ A विल डिवाइड दिस पावर. दैट मीन्स ऑर्डर ऑफ A डिवाइड्स mn. सो इसका मतलब क्या हो गया? कि ऑर्डर ऑफ A को फाइनाइट होना ही पड़ेगा. दैट मीन्स ऑर्डर ऑफ A इज़ फाइनाइट. But what was G? G was cyclic group generated by A. So order of G is same as order of A. And यहाँ पर हम कह रहे हैं order of A finite है. So we get order of G is finite. This is a contradiction. Why? Because हमें starting में ही दिया हुआ है कि G is infinite. तो हमें ये contradiction क्यों मिली है? Because हमने ये जो suppose किया था, assumption की थी, ये wrong थी. सो हमारी ये जो assumption जिसको मैंने 1 नंबर दिया है, हमने क्या assume किया था? दैट H इज़ फाइनाइट. सो दिस 1 assumption इज़ wrong. दैट मीन्स H must be infinite. That is order of H must be infinite.